Welcome to the deep dive. You know, when blockchain comes up, gosh, so many people immediately think crypto, right?
Almost always, yeah.
Yeah.
Bitcoin, Ethereum prices.
Exactly. But we were wondering, what's really going on underneath all that? What are the actual practical ways this tech is being used right now, beyond the speculation?
Yeah, the real world stuff.
That's the mission today. We're going to explore the, honestly, quite surprising and tangible applications of blockchain across a whole bunch of different industries,
Uh-huh.
giving you, hopefully, a clear understanding of its actual power.
Absolutely. And to get there, we've pulled together a really diverse set of sources. Quite a stack, actually.
Oh, yeah. What have we got?
Okay, so there's a systematic review focused specifically on blockchain and healthcare. Okay, very academic. Then a great YouTube discussion just highlighting lots of real-world use cases.
Okay.
A scientific paper investigating blockchain for secure electronic voting. Really interesting stuff there. An article from Built In showcasing how governments are actually using this.
Wow. Okay.
Yeah. Then a Casper Network piece, drilling down on its impact in real estate. A consensus article exploring blockchain in the energy
It's a
sector.
jump gate, too. Okay.
Yep. A paper on managing digital copyright with blockchain think artists, musicians. An OSL overview explaining decentralized autonomous organizations, or DAOs. Heard of them?
Vaguely, yeah. DAOs. Sounds intriguing.
We'll get into it.
Oh.
A Parengat Technologies article outlining the sort of challenges and solutions for broader adoption. Why isn't it everywhere yet? A Deloitte report dissecting blockchain's role in supply chain transparency. Big one.
Makes sense.
And even a look at a Reddit thread where people are just, discussing their own experiences with
Yeah.
real-world blockchain stuff.
Wow. Okay, that's a serious deep dive list. So the big question for a lot of people, myself included sometimes, is if it's not just about Bitcoin, what is blockchain fundamentally bringing to the table? Because it's that core thing, isn't it, that's letting it branch out everywhere else.
Exactly. What's fascinating and kind of the key
Yeah.
is that at its heart, blockchain provides a way to create a shared, tamper-proof record of information.
Tamper-proof, like unchangeable.
Pretty much.
Yeah.
Think of it like a digital ledger, but instead of one person holding it, lots of people have a copy.
Okay.
And every new entry, every transaction has to be verified and agreed upon by, well, not necessarily everyone, but by the network based on set rules. And once something is recorded, it's incredibly difficult, practically impossible in many cases, to change it without everyone noticing.
Ah, okay, so it's about trust.
It's about establishing trust and transparency without needing a central middleman like a bank or, some other
Right.
authority. That's the powerful bit that applies across so many different areas.
Okay, that makes sense. Let's start with something super tangible then, like the food we eat. You see organic on a label, right?
Yep.
But how do you actually know? It feels like you just have to trust the sticker sometimes.
Totally. And that's where it gets interesting. Blockchain is being used here to create a verifiable history for products, like those organic bananas you mentioned.
So you can track them.
Yeah, track their journey right from the farm through transport all the way to your shopping cart. It's like a digital receipt trail.
Huh.
Right. The YouTube discussion we watched really drove this home, how blockchain can provide this, irrefutable history.
Irrefutable. Strong word.
Well, yeah. Every step, the farmer, the shipper, the store, they can all record their bit of information onto the blockchain.
Uh-huh.
And because this record is immutable, unchangeable, and shared, it creates a much higher level of trust in where that product came from and how it was handled. Much better than, say, easily fake paper records.
So it's not just, is it organic, but maybe, was it ethically sourced?
Exactly. It could be about ensuring fair wages for coffee farmers or, verifying sustainable fishing practices. The possibilities are pretty broad.
And this isn't just small-scale niche stuff. The Deloitte report mentioned something called TradeLenses.
Ah, yes. TradeLens, that's a big one. It's a collaboration, mainly IBM and Maersk originally, using what's called a permissioned blockchain.
Okay, permissioned. What's that mean differently?
So think of Bitcoin's blockchain that's public. Anyone can join, see the transactions, potentially mine it.
Right.
A permissioned blockchain is more like a private club. Only authorized participants, ones who are invited and vetted, can access and contribute to the ledger.
Ah, okay. Like businesses working together.
Precisely. In TradeLens, these participants are the big players in global shipping. The shipping lines, the ports, customs agencies, freight forwarders.
The whole ecosystem.
Exactly.
Yeah.
All working together on this shared, unalterable record of what's happening with shipments. This shared visibility, This single source of truth can massively cut down on delays, paperwork, disputes, you name it.
That makes a ton of sense. A trusted network for known players. We even saw an example with FedEx exploring smart contracts for transferring ownership of goods.
Right, smart contracts, that's another key piece of the puzzle.
Okay, break that down. What are smart contracts?
Think of a smart contract as basically self-executing agreement. It's written in code, lives on the blockchain.
Coke instead of legal jargon.
Well, often alongside it, but yeah.
Yeah.
The terms of the agreement, like if X happens, then do Y, are baked right into the code.
Okay.
And the blockchain network automatically enforces those terms when the predefined conditions are met. No need for manual intervention necessarily.
So in the FedEx example,
A smart contract could automatically trigger the transfer of legal ownership of a package as soon as, say, a GPS sensor confirms its delivery coordinates, and that's recorded on the blockchain.
wow, okay. Automated.
Very. And that Deloitte report mentioned this kind of real-time tracking, often using sensors, IoT devices, feeding data onto the blockchain. It's incredibly valuable for monitoring sensitive stuff.
Like what?
Like vaccines, needing specific temperatures. Or fresh produce. You can ensure they stayed within the right conditions throughout the whole journey.
Ah, the cold chain.
Exactly. But it also applies to high-value things like gold or diamonds. The Parangat Technologies article also really emphasized this, creating a clear, auditable chain of custody. You know exactly where it's been.
So this ability, this unchangeable record plus automated agreements, sounds like it could really help enforce ethical stuff too.
Definitely.
Like if a company says their wood is sustainably harvested.
Blockchain could potentially provide the proof.
Yeah.
Each step, from the forest to the retailer, could be logged. If standards weren't met somewhere, it'd be, well, harder to hide.
Right. It anchors the claims in something verifiable.
Exactly. It helps build stronger trust with consumers who, increasingly care about the ethical and environmental side of things. It goes beyond just marketing spin.
Okay, let's switch gears. Another area where, frankly, we all feel the pain points sometimes. Healthcare.
Oh, yeah. Medical records.
A nightmare. Getting records from one doctor to another. Could blockchain offer a better way?
The systematic review we looked at really points towards yes. Big potential here.
Yeah.
Imagine your medical records stored securely, maybe encrypted, in a kind of digital vault on a blockchain.
Okay.
A vault that you control. You hold the keys, essentially, and you grant access to different hospitals or doctors only when needed.
So I control my data, not the hospital system.
That's the idea. It can solve huge problems with interoperability, getting different systems to talk to each other, which means, hopefully, more informed, more efficient care, less repeating tests.
Yeah, less hassle, maybe even safer in emergencies if they can get critical info fast. And it's not just about the records themselves, is it? The YouTube discussion mentioned tracking medications.
Counterfeit drugs.
Huh.
Huge, dangerous problem globally.
Right.
So by recording the origin and every single transfer of a batch of medication on the blockchain, you create this super secure, auditable trail.
Like the organic bananas, but for pills?
Kind of, yeah. It makes it much, much harder for fake drugs to sneak into the supply chain. And if they do, it's easier to spot them and track down where things went wrong. That sounds vital.
It is. And Deloitte also had this interesting proof of concept, biotrack and trace.
What's
They explored using blockchain to streamline how patient consent is managed for clinical trials and how biological samples, blood, tissue, are tracked.
Oh, that sounds complex normally.
Extremely. Lots of paperwork, tracking, potential for mix-ups. Blockchain could provide a single, secure place to manage consent and track those samples from the patient to the lab through analysis, addressing lots of logistical headaches and research.
So instead of all these different databases and paper forms that don't connect,
You'd have this unified, transparent view, hopefully improving efficiency, reducing errors.
and giving patients more control.
Potentially, yes. More insight into how their data and samples are actually being used. The systematic review also stressed how blockchain could significantly improve electronic health records, EHRs.
EHRs, is that different from EMRs? I always mix those up.
Yeah, easy to do. Think of EMRs, electronic medical records, as like the digital version of the paper charts within one doctor's office or hospital. Okay, internal use.
Right. EHRs, electronic health records, are designed to go broader. They contain information from all the clinicians involved in a patient's care, and they're built to securely share that information across different healthcare providers.
Ah, the bigger picture.
Exactly. And blockchain could help by making it easier to integrate data from all those different sources reliably and ensuring the accuracy of that shared record, giving a more holistic view of your health journey.
Okay, makes sense. Wow. Okay, from something as personal as our health records, let's jump to something fundamental to democracy. Voting.
Always hot topic, election security.
Constantly. Concerns about fraud, lost ballots, hacking. Could blockchain actually make elections more secure and transparent?
Well, the scientific article we dug into explores exactly that. The core idea is pretty compelling. Record votes on that digital ledger we talked about, the one that's incredibly hard to tamper with.
Right, the immutable ledger.
Exactly. And because the ledger is distributed across many computers, these decentralized nodes, there's no single server to hack, no single point of failure or manipulation.
Decentralized, okay.
Plus, blockchain offers something called end-to-end verifiability.
What's that mean?
In theory, it means a voter could potentially check that their specific vote was correctly included in the final tally, but without revealing who they actually voted for. So, maintaining anonymity while allowing verification.
Huh. That could address both the lost ballot problem and the was my vote counted correctly concern.
Potentially, yes. It tackles worries about both accidental errors and deliberate fraud.
It's like someone on that YouTube thread commented, online banking level security for casting your ballot. That's a powerful image.
It is a powerful image. And the scientific article really laid out the key security requirements for any voting system. Things like anonymity, privacy, robustness against attacks, transparency of the process, and that verifiability we mentioned.
And blockchain seems to tick some of those boxes.
On paper, its inherent design seems to address many of them quite well. For instance, the transparency part. Any attempt to mess with the vote count on the public ledger should, in theory, be visible to the whole network.
But there's always a but, isn't there?
Usually. The research paper also highlighted some pretty significant hurdles. Scalability is a big one, and transaction speed.
Right. I mean, think about a national election. Millions of votes cast in a fairly short window.
Exactly. Could a system like, say, Bitcoin, which handles maybe 7 transactions per second, cope with millions of votes per hour?
Doesn't sound like
No. That's a crucial bottleneck. The scientific paper even had a table comparing speeds. Current public blockchains like Bitcoin and Ethereum are way slower than traditional payment systems, let alone what an election might need.
So what's the solution?
People are working on it. Things like sharding, basically splitting the blockchain into smaller, faster pieces. And layer 2 network systems built on top of the main blockchain to handle transactions more quickly off-chain. The Parangat article mentioned these two as key scaling solutions.
Okay, so tactical fixes are being explored. And aren't there already companies trying this? The research mentioned Follow My Vote, Polis.
Yes, absolutely. There are platforms actively developing and testing different approaches to use blockchain for voting. They're trying to figure out the best way to implement it.
But it's not widespread yet.
No. The scientific article was also quite cautious, pointing out these ongoing limitations. Scalability needs major improvement. There are still security concerns about potential attack vectors specific to voting protocols. And there's really a lack of universally agreed upon standards for how blockchain voting should even work. It's definitely still an evolving field.
So the potential seems huge. The reality, still some big technical mountains to climb before we're likely voting for president on a blockchain.
That sums it up pretty well. Intriguing, but not quite ready for prime time on a massive scale yet.
Okay, now let's flip it. Instead of citizens using blockchain, what about governments themselves? Are they starting to use this technology?
Oh yes, the built-in article gave some really fascinating examples. They're definitely experimenting and, in some cases, implementing.
Like how?
Well, think about the complexities of distributing public assistance or foreign aid, getting money or resources to the right people efficiently and without leakage.
Always a challenge.
Right. So the UN World Food Program has this initiative called Building Blocks. It's built on the Ethereum blockchain.
Okay.
They've used it to deliver aid, like food vouchers, directly to refugees in camps, using cryptocurrency-based transfers tied to things like iris scans for identification.
Wow, so it cuts out intermediaries.
Exactly. Reduces the time, the cost, the potential for fraud or funds going astray. The article mentioned Denmark's Ministry of Foreign Affairs seeing similar benefits in their aid programs too, getting resources directly to those who need them.
That's genuinely impactful. What else? The article mentioned smart contracts again, but for infrastructure projects.
Yeah, imagine a city government hiring a company to, say, build a new bridge. The contract, with all the payment schedules, completion deadlines, quality checks, penalties, could be encoded as a smart contract on a blockchain.
And it would just run itself.
Kind of. Payments could be automatically released from escrow when certain milestones are met and verified, maybe through sensor data, drone inspections, whatever is agreed and recorded on the chain.
Less paperwork, fewer disputes, maybe.
That's the hope. Reduces the need for constant manual oversight, makes the process more transparent. Dubai is even exploring this with something called the Court of Blockchain, looking at how smart contracts could integrate with their judicial system for efficiency.
A court of blockchain sounds futuristic.
It does, but it shows the level of interest. And think about basic government record keeping. Passports, birth certificates, land titles, voter registration.
All critical records, and often paper-based or in siloed databases.
Exactly. So initiatives like the Illinois Blockchain Initiative, the Delaware Blockchain Initiative, efforts in Australia, they're all exploring how blockchain security and immutability can make these vital records less vulnerable to fraud or loss and easier to manage and verify.
Secure digital identities, basically.
That's a big part of it. The built-in article specifically mentioned how secure identity encryption on a blockchain could help prevent hacking and fraud in these crucial systems.
And even law enforcement is looking at it.
Seems so. For things like maintaining the chain of custody for evidence.
Proving evidence hasn't been tampered with.
Exactly. Companies like Chronicled are developing blockchain solutions for that, creating a tamper-proof log of who handled evidence and when, and others like Elliptic build tools to help track illicit cryptocurrency transactions, helping investigations.
So governments are definitely seeing potential for efficiency, transparency, and security. Okay, moving to another big sector, real estate. Buying a house, so much paperwork, so many steps.
Tell me about it. It can be incredibly cumbersome. The piece from Casper Network really highlighted how blockchain could smooth things out.
How so?
Well, one aspect is improving how investors and tenants are identified and verified, adding a layer of security and trust right at the start.
Okay, ID verification makes sense.
But more broadly, it's about streamlining the whole process of tracking and verifying the actual real estate transactions. Who owns what? The history of the property. Cutting down on the manual processes and reliance on intermediaries, like title companies, potentially.
So a clearer, faster, more transparent record of property ownership and transfers.
That's the goal. And smart contracts, again, play a big role here.
Automating parts of the deal.
Yeah, automating escrow, title transfers, payments once conditions are met, potentially speeding everything up and reducing errors or fraud.
Could it, cut out real estate agents?
Interestingly, the Casper Network article suggested maybe not cutting them out, but changing their role. It proposed that agents could actually become key players in creating and managing these secure smart contracts for their clients, adding new value.
Huh. So evolving the profession, not eliminating it. Interesting angle.
Yeah.
Okay, next up, the energy sector. How does blockchain fit in there? Seems less obvious, maybe.
You might think so, but the consensus article laid out several promising areas. For utility companies, for instance, tracking the supply chain for grid materials. Where did that transformer come from? Is it certified?
Supply chain again, but for energy infrastructure.
Exactly. And then there's managing the distribution of renewable energy. This gets really interesting.
How?
Imagine more decentralized grids, maybe peer-to-peer trading of excess solar power from your rooftop panels directly to your neighbor. Blockchain could provide the platform for tracking that energy flow and handling the payments automatically via smart contracts.
Wow. Okay. A truly smart grid.
Potentially. And just manage the sheer volume of data in the energy sector, consumption data, production data, grid performance.
Must be massive.
Huge. The article gave the example of Chile's National Energy Commission using the Ethereum blockchain to record and track key energy data. Why? For transparency and immutability.
So everyone sees the same accurate data.
Exactly. Helps ensure accuracy, prevents disputes, aids planning. It's also being looked at for making commodity trading, oil, gas, electricity futures cheaper and more efficient, cutting out intermediaries again.
And smart contracts in oil and gas production itself.
Yeah, the consensus piece mentioned using smart legal contracts, blending code and legal text to manage and track complex operational data, agreements between partners, royalty payments, bringing more accountability to that complex industry.
Okay, that's a lot of industrial applications. Let's shift to the creative world. Artists, musicians, writers. Digital copyright is such a headache.
A massive headache. Piracy, proving ownership, getting paid fairly.
So can blockchain help empower creators?
The paper we read on blockchain-based digital copyright management systems thinks so. It envisions a decentralized system.
Decentralized copyright.
Yeah. Creators could register their works, songs, photos, articles directly onto the blockchain, creating a time-stamped, immutable proof of creation and ownership.
Like a global public registry.
Kind of. And smart contracts could automate the licensing, define the rules. How can someone use this work? What royalties are due? Payments could be triggered automatically when the work is used according to the license.
So easier licensing, automatic payments.
That's the potential. The system often includes portals, one for creators to manage their rights, one for consumers or businesses to find content and acquire licenses legally.
Could it open up new models?
Definitely. The paper talked about things like fractional ownership. Imagine owning a tiny share of the rights to a hit song. Or micro-licensing, easily paying a small fee to use an image in a blog post. It could make using copyrighted material legally much simpler.
And does it actually work, performance-wise?
The research indicated, yeah, these systems could handle a pretty decent volume of registrations and licensing transactions efficiently, looking at things like throughput and latency. So, technically feasible.
That sounds like it could genuinely shift the power back towards creators a bit, giving them more control, more direct monetization.
That's certainly the hope and the driving force behind exploring these systems.
Okay, now, we mentioned them earlier. DAOs, Decentralized Autonomous Organizations. Sounds very sci-fi. What actually are they?
Right. The OSL overview gave a good explanation. Think of a DAO as basically an organization run by code.
Run by code, no CEO, no managers.
Often, yes, or at least a very different structure. The rules of the organization, how decisions are made, how funds are spent, are encoded in smart contracts on a blockchain.
So the blockchain enforces the rules.
Exactly. It operates without that traditional centralized management hierarchy. Decisions are typically made collectively by members, often people who hold special governance tokens.
Voting with tokens.
Usually, yeah. Token holders propose ideas, vote on proposals, and the outcomes are executed automatically by the smart contracts if the vote passes.
And it's all transparent.
Highly transparent. All the rules, the voting, the transactions, the treasury balance, it's all visible on the public blockchain. And immutable, of course.
Yeah.
It creates this auditable way for groups, even globally distributed ones, to collaborate and govern themselves.
So what are they used for?
All sorts of things. Managing decentralized finance protocols, funding projects, governing online communities, collective investment. It's a really novel structure for collective action.
A truly decentralized way to organize. Wild. Okay, so we've seen all these incredible potential applications from coffee beans to voting to DAOs. But why isn't blockchain everywhere already? What are the roadblocks?
The adoption challenges. The Paragat Technologies article laid these out quite well. There are definitely still hurdles.
Like what? What's number one?
Trust is still a big one, ironically. Trust in the technology itself, sure, but also trust among the participants using a blockchain.
How do you fix that?
Well, permission blockchains help, like we discussed with TradeLens. You know who the players are. Establishing trust anchors. Reputable organizations within a network who vouch for data that also helps build confidence. Collaboration is key.
Okay. And scalability keeps coming up. The speed issue.
Absolutely. Especially for public blockchains aiming for mass adoption, like in voting or maybe consumer payments. It's just too slow right now for many uses.
But fixes are being worked on.
Constantly. We mentioned layer 2s like the Lightning Network for Bitcoin, sharding. Also just building fundamentally faster, higher capacity layer 1 blockchains from scratch and improving existing ones. It's a major focus of development.
What about getting different blockchains to talk to each other?
Interoperability. Yeah, that's another big challenge. Right now, it's often like having different internets that can't easily communicate.
So you're locked into one system.
Can be, yeah. But projects like Arc, Cosmos, Polkadot, they're specifically focused on building bridges and protocols so that different blockchain networks can securely exchange information and assets. That's crucial for the ecosystem to really mature.
Okay. Security and privacy, especially with sensitive data like health records.
Huge concerns. Public blockchains are transparent, which isn't always good for privacy. So private or consortium blockchains where access is restricted are one solution.
But you lose some decentralization, maybe.
There can be trade-offs. But also, there's a lot of progress in privacy-enhancing tech, like zero-knowledge proofs.
Zero knowledge. Sounds magical.
It kind of is. It allows you to prove that something is true, like I have enough funds for this transaction or this medical record is valid, without revealing the underlying sensitive data itself. Big potential there.
Wow. Okay. What else is holding things back?
Perception, maybe?
Yeah.
It's still heavily tied to crypto in many people's minds, sometimes with negative baggage from scams or volatility. Just general awareness and education about the other uses is needed.
And finding people who actually know how to build and use this stuff.
The skills gap, definitely. Need more developers, more experts, and making the technology easier for regular users and businesses to interact with better user interfaces, simpler tools. Plus, fostering collaboration, like that blockchain for clinical supply chain industry working group mentioned in the Deloitte report, getting competitors to work together on standards.
So quite a few hurdles, but sounds like active work is happening on all fronts.
Absolutely. Trust, scalability, interoperability, privacy, perception, skills, they're all being tackled. The technology is maturing fast.
Okay, so to kind of bring this all together, this deep dive really shows, I think, that blockchain is clearly about way, way more than just cryptocurrencies.
Night and day, really. Crypto is just one application, maybe the first big one, but the underlying tech is so much broader.
Yeah, we've explored how its core ideas, that shared ledger, the immutability, the smart contracts, are being applied to make things more transparent, more secure, more efficient.
Across just about everything, from tracking our coffee and our medicines.
To maybe, eventually, how we vote, how our governments operate, how artists manage their rights, even how organizations themselves are structured with DAOs.
It really boils down to establishing trust and streamlining processes in a way that doesn't rely on a single central point of control. That's the revolutionary part.
A tool for building trust in a digital world.
Well put. It's a versatile toolkit for solving a whole range of real-world problems where trust, transparency, or efficiency are lacking.
Okay, so that brings us to our final thought for you, listening in. Think about those core principles we've discussed, that shared, unchangeable record, the idea of consensus, automated agreements.
Yeah, where else could that apply?
Exactly. Where else in your life, maybe your job, your industry, could these concepts be used? To fix something broken or maybe create something totally new.
What other fields are just waiting for their own blockchain deep dive, you know?
Yeah. What other industries might be ripe for this kind of transformation? Definitely some food for thought there.
For sure.
Well, thanks for joining us on the deep dive.